All right, guys, this is chapter 4, lesson 3. This is day 2 of it. We're going to look at the tangents and cotangents. And there's a little noise in the hall, but we're just in the passing period. You're going to hear the bell in a minute, but it's okay. So we did yesterday the secant and cosecant. We found that was fairly easy to graph those. You just graphed the sine or cosine and made little loops coming off the top or bottom. The tangent cotangent isn't quite as simple, but it's also not quite as important, so the tangent cotangent. So I'm going to kind of give you the main ideas, but we don't dwell on these a whole lot. And so to start with the tangent, we're just going to give you the graph and see what it looks like. So you can pull out your calculator, and let's just see what a tangent graph looks like. So we'll go to y equals, clear these things out, and let's see, we'll go tangent of x. Check your mode, make sure you're in radians. We're always in radians. And for a window, that zoom trig is always kind of a nice window, so zoom 7 or zoom trig. And here's our tangent graph. And it's basically, we could go through and plot all the points and understand it, but we don't use this nearly as frequently as sine and cosine. And so it's something that's a little bit easier just to kind of take a look at it, see some of the main ideas, and if you have those main ideas, that's all you're going to need to know. First thing you need to look at when you look at the tangent graph, you'll notice it repeats. You've got one here. Oh, look, you've got the same thing. You've got the same thing. You've got the same thing. So it's periodic, just like the other ones. One thing you'll notice about the period, though, unlike sine, cosine, secant, cosecant that repeat every 2 pi, here's 0, here's pi, here's negative pi. It repeats, but your period now is just pi for both a tangent and a cotangent. So that's one thing you want to note. The period for a tangent graph is pi, not 2 pi. You'll also want to note it opens, it goes up to the right. There's our passing period. Hopefully now I'll get a little quieter. And it goes down to the left. When we see the cotangent graph, you're going to realize it does the exact opposite. It'll go up to the left and down to the right. But for the tangent, it's up to the right, down to the left. And then the other things you'll want to know about a tangent graph, remember the tangent of 0 was 0? We did it a long time ago. Well, that's this point. And from this point, you open up to the right, down to the left. You get that. And then once you get to pi halves, your tangent graph is undefined. You'd have a vertical asymptote in there. Or at negative pi halves, you'd have a vertical asymptote in there. So the tangent of 0 is 0. And at pi halves, 3 pi halves, 5 pi halves, etc., you would have vertical asymptotes. And every value of pi, the tangent of pi, you'd be back to 0. The tangent of 2 pi, that's a 2 pi, you'd be back to 0. And so with that little bit of information, you should be able to sketch a tangent graph. So every value of pi, it's a 0. So 0, pi, 2 pi, negative pi, you get zeros. You go up to the right, down to the left, and right in the middle of your zeros, between negative pi and pi at negative pi halves, vertical asymptote, between 0 and pi halves, vertical asymptote, between pi and 2 pi, 3 pi halves, vertical asymptote, and that would really be enough that you need to know to remember how to graph the tangent graph. All right, let's look at the cotangent graph. It's going to be pretty much the same thing. So we've got the tangent, and we've got the cotangent. Let's look at this on our calculator. We have y equals, and to get cotangent, I'm going to go 1 divided by tangent.
Come back in a half hour.
Yeah, even 5 or 10 minutes max. So 1 divided by tangent, and I'll hit graph. Oh, and that reminds me of a random fact. Did you guys know that jellyfish are 98% water? And did you know if you put a jellyfish on the beach, they just evaporate? That was a random fact, courtesy one of your classmates. Okay, here is our cotangent graph. Look, it looks kind of like the tangent graph with a few differences in here. All right, and some things the same. So here's our cotangent graph. First of all, would you agree the period is pi again? It repeats. And look, here's 0, here's pi, here's negative pi. We're getting that same graph every pi. This time, it goes down to the right or up to the left. So down to the right or up to the left. So if you look at this, you go down to the right up to the left, down to the right, up to the left. We've got that. And now our points have switched around. And here comes one of my favorite calculus students. Any comments on trig? Don't you love trigonometry?
I guess.
He's nodding his head.
Calculus more, though.
Ooh, all right, so after trig, guys, you can take calculus. So this opens down to the right, up to the left, and all these points got switched. The tangent of 0 was 0. Now look, the cotangent of 0, or pi, or 2 pi, that's where you're going to get the vertical asymptotes. And on the tangent graph where we got the vertical asymptotes, the pi halves, the 3 pi halves, the 5 pi halves, that's where our zeros are at now. So everything gets switched around with it. Your zeros and your vertical asymptotes are interchanged compared with a tangent graph. And again, we could derive all that with graphing points and things like that, but we don't use these enough that it's really worth the trouble. Sines and cosines were our main focus. Based on your last quiz, you guys are doing a really nice job with those. And this is just more so that you know what they look like, but they are not used quite as much as sines and cosines. All right, one last thing here, then we'll do a couple practice problems. If you get confused, like, wait a minute, what are zeros, where are the zeros, where are the vertical asymptotes? One way to remember it is tangent is the sine divided by the cosine. And if you think about your key points, we have x, we've got the sine of x. Remember your key points is 0, pi halves pi, 3 pi halves 2 pi. And for sine, you should remember, this is how they go. For cosine, we've got x, cosine of x, the same key points. And cosine, you should remember, they go 1, 0, negative 1, 0, 1. So let's look at sine for a minute. I'm sorry, look at tangent for a minute. Sorry about that. Let's look at tangent for a minute. And tangent is sine over cosine. So would it make sense the tangent of 0? Oh, look. It's going to be the sine of 0 over the cosine of 0. But wait a minute. The sine of 0 is 0. Cosine of 0 is 1. I get 0 over 1. I get 0. Or the tangent of pi. It's the sine of pi over the cosine of pi. But look at that. The sine of pi is 0. So everywhere the sine is 0, look at that. So isn't the tangent. How about tangent of pi halves? That's the sine of pi halves over the cosine of pi halves. But wait a minute. The sine of pi halves is 1. The cosine of pi halves is 0. You can't divide by 0. So since tangent is sine over cosine, everywhere the sine is 0, 0, pi, 2 pi, then also the tangent is 0. Everywhere the cosine is 0, pi halves, 3 pi halves, that makes the bottom of your fraction 0, so that makes the tangent undefined.
Can you go ask your question?
Sounds good. Similarly, for the cotangent graph, it's cosine over sine. When would the cotangent graph be 0? When the top is 0. So look at that. It's going to be 0 at pi halves, 3 pi halves. When is cotangent undefined? When the bottom is 0. So it's 0, pi, 2 pi. So again, a lot of trig comes down to these basic facts here. And you can remember tangent or cotangent, or you can just remember tangent, cotangent in terms of sine and cosine, and these charts, and that should kind of help you with your graphs. So tangent is 0 when sine is 0. Cotangent is 0 when cosine is 0. All right, let's try a couple of these problems. And again, they're not going to be nearly the difficulty level that we did with sines and cosines. We're not going to have the 4 different things going on with a vertical translation and a phase shift and a period and an amplitude change and things like that. We're going to keep them fairly straightforward. There'll be like 1 or 2 things going on, but not all 4 things simultaneously. Okay, so here we've got the tangent of 2x. We kind of sketch out an axis here. We think about our basic tangent graph, and we know at 0, pi, 2 pi, etc., then the tangent of those values was 0. We look up here and we realize, wait a minute, that's not the tangent of x, it's the tangent of 2x. Well, guys, just like sines and cosines, we do the same thing with this too as what we did with the sines and cosines. we divide all our x coordinates. So this is our x, or I guess I could call that an x instead of a theta. We divide our x's by 2, or what does this do? It makes our tangent graph occur twice as quickly. So I still have 0. Instead of pi, I divide it by 2. I'll call that pi halves. Instead of 2 pi, I'll divide it by 2. So let me erase that. And 2 pi divided by 2 is pi. And I know these will be the zeros of my graph. Are coming over this way. I know it's a negative pi halves and a negative pi. So I've got my zeros. I know my vertical asymptotes are right in the middle of that. Hopefully you're good with fractions between 0 and pi halves. Isn't that a fourth? So pi fourths, 3 pi fourths, negative pi fourths, etc. And a tangent graph I know goes up to the right and down to the left. So I get a very similar graph to my regular tangent graph, but just like sines and cosines, I know that 2 in here makes it occur twice as frequently. All right, let's try another one. Here's the cotangent. And now I notice it's x minus pi fourths. I think you can probably guess what's going on here. The minus pi fourths, isn't that going to shift the graph to the right? Pi fourths. My cotangent graph, my zeros, for the cotangent graph, I knew they used to be at pi halves, 3 pi halves, etc. Now I shift them all to the right, pi fourths, so I have to add on a pi fourths to these. And a half plus a fourth gives me 3 pi fourths. 3 halves and a fourth give me 7 pi fourths. I can keep doing this, or I can see a pattern. It's going to be an 11 pi fourths. And going the other way would be a negative pi fourths. So I can sketch this graph out. It's going to be a cotangent graph. My zeros are at negative pi fourths, 3 pi fourths, 7 pi fourths. Those will be my zeros. I know I have vertical asymptotes right in the middle. So wouldn't that be 5 pi fourths, 5 fourths, negative 3 pi fourths? And I know my graph, it doesn't go up to the right, it goes down to the right and up to the left. Down to the right, up to the left, down to the right, up to the left. So if you had the sines and cosines down, if you knew how they were shifted, tangents, cotangents are shifted in the same manner. Okay, very last problem. 2 plus 3 tangent of x. Two different things going on here. Neither one of real great consequence. The 2 shifts the graph up 2, no big deal. The 3 affects the amplitude, which is kind of a strange concept for a tangent graph, because didn't it shoot off to infinity already? It goes up to the right, down to the left. So how can you change that amplitude? Well, what you would do is you'd make that shoot off to infinity even quicker, so it'd go steeper to infinity or steeper down to negative infinity. But it doesn't really affect it the way sines and cosines, where it went up to 3 or down to 3, because it was going off to infinity regardless. It'll just go there faster. So let's think about this graph. Sketch my axes here. Remember tangent? It was at 0 and pi. These are my zeros. 2 pi. Those are my zeros. But now I have to lift it up 2. So I lift those up 2, and now here's where my zeros would be. The vertical asymptotes haven't changed. Pi halves, 3 pi halves, 5 pi halves, etc. And what does a tangent graph look like? It goes up to the right and down to the left. And I'm trying to make it go a little steeper because of the 3. But that's basically the effect that the 3 would have on the graph. It makes it go steeper, off to infinity. And again, you can kind of see this whole graph was lifted up 2, which makes sense based on sines and cosines. You have that plus 2 in there, and it shifts it up 2. So that completes our lesson for the tangents and the cotangents. And again, you can kind of start to take a look at the homework tomorrow, and that will pretty much complete the chapter for us. So hopefully that all makes sense.